And the practice are on the back table. This one didn't get into my packet because I couldn't decide which unit to put it in until the end here. So, okay, piecewise functions. A little bit something that's different. So, this is going to be made up of two functions each with its own, now let me explain this a little better, its own domain, but I'm going to call it restrictions. So we've all had at some point in our mathematical life a point where you saw something where it said like, hey, y equals 4x plus 2 if x equals 3, what does y equal? Okay, you're like, well, I just stick the 3 in there and I get the answer. That's kind of like what piecewise is, except we have more options. So let me explain. So they give us a couple of things here, and they put these little if statements in. They say find each value. Okay, here's what we're going to do. We're going to kind of write a couple of notes here to the side too. What's the x value? And the reason I put x value in parentheses is that's the x value we're working with on these. Instead of just saying y equals, it's saying, hey, this function thing, these expressions right here, so I want to figure out what the answer is when x equals -5. But here's the part that's a little extra. Instead of just giving us one equation and saying plug it in here, there's two equations with restrictions or their own domain. So, let me put this in blue. My next question is, which inequality does x work for? You're like, okay, so what do you mean? The number in parentheses, if I plug it in to the blue box here, is only going to work for one of these. It's not going to work for both. So here's kind of what we're asking. We're saying, okay, so if I plug in -5 for x, is -5 less than -2? Ooh. Would you rather owe your friend $5 or $2? 2. Okay, so 2 is greater. We'd rather owe them less. So this is true. If I wasn't sure, Hardy, I don't know. This gets to be a little bit tricky. What I could do, and there's nothing wrong with this. I've had people do this lots of times. If you ever took the two numbers in doubt because you weren't sure and put them on a number line, the one further to the right is bigger every time. So in this case, -5 I know would be less. So this is true. So what does that mean? This is the last part. We're almost there. Never think there'd be this much work for one problem. We're going to substitute the correct expression and solve it. So, for instance, on this one, since we said the top one is true, since -5 is less than -2, we're going to take this, we're going to use parentheses. And we're just going to plug it into the top one, because -5 isn't greater than -2, so I can't put it in that one. We have to pick the right one. And once we do, we can either use our noggin or we can use the calculator and get our solution. And so for each of these, we keep going back to the blue box. Now this one's a little more interesting. Is -2 less than -2? You're like, let me ask it this one then. Is -2 greater than or equal to -2? Yeah. -2 is equal to -2. So this time, we're going to use the one on the bottom. So we're allowing only one equation, one expression per time, but we're always trying to figure out the number we plug in from here, our x value, is only going to fit in one of them. So on this last one, same thing. The x value is 7, okay. Is 7 less than -2? I think you know this one. My crew has gone quiet on me. I don't think 7's less than -2. Is 7 greater than -2? Yeah. Because again, greater than's just eating the bigger number. The arrow eats the bigger number. So it's back to the bottom one more time. And again, you can type that whole thing in the calculator. I'm just kind of working it out as I go. So that's why I'm putting the extra steps in. But we're just filling in numbers based on what they are. And sometimes we're going to get some of these that are a little larger. But again, we just got to kind of work it out. And again, even if I need to have a number line, it's not a bad thing. It doesn't make you not smart. It just means, hey, we got something we got to figure out. All right, let's try this. More volume this time, people. More volume. If x is 2, which one of the three, the top, the middle, or the bottom inequality would 2 fit into? Two is definitely greater than 1. That's true. So we slide over. That's the one that we're going to plug this into. And I would suggest, so I get that off of there, if it's bigger like this, I would go ahead and use the calculator. And again, if you're bigger than squared, it's this up arrow button that we're looking for. So we get that typed in. You can do it manually, but sometimes it's easier to make errors with that. So we're just kind of working at getting used to that a bit. Let's see here. -1. -1 bigger than positive. Negative is not bigger than positive, so it's not that one. Is -1 between -4 and +1? Yep. Even if I had a number line, I'd be able to see that. So we slide over. Here's the part that's interesting or tricky. That negative that's there has to be there, and I'm substituting in for x. So I'm putting the -1 in there. That's a lot of negativity. The opposite of -1 minus 1. Yeah, I'm even typing that in. I'm typing it in exactly like I see it. Yep, that'd be 0. Because the opposite of -1 would be +1. -1 is 0. So it's all about that inequality box when we're looking at these. Is -6 less than -4? Yeah, because let me pull this out again. So here's -6. Here's -4. Okay. The one on the left is less. -6 is less than -4. So that's how we're figuring out which one to plug in. And if you're going to do the calculator on this one we might be able to just do. Half of -6 is -3. Plus 3 is 0. But if we're not feeling it, just make sure we use the parenthesis. When we're doing the fraction, and we can still get there. So, for any time we're evaluating, that's all we're doing. Look in the box, find your x value, find which one it works, and we're just plugging it in or substituting into the one that it's with. For the graphing part, I'm going to make a suggestion. When we get to the graphing, I would use the calculator. If you're comfortable graphing lines in slope-intercept form, you can, but we'll get a couple of instructions to help out in here. So we're going to graph the line using y equals here. So here's y equals. We can get that up. If something's in there, I can just hit clear. That'll wipe out whatever's in that spot here. So, other little things to note. If you haven't used these before, the x, t, theta, n button is x. So if I just want x, that's the one I want. I don't want to use alpha to do x. I just want to use this one. That's all I have for this one, just x. So I can look at the line. I can hit graph. Okay, you're like, yep, there. See the line. There it is. But I need to have accurate points. So next, to get the chart, which we like here, that is second. If I did it right, second in graph. And this chart's going to pop up with all these x and y values. So here's the thing, though. I don't want all of them. I only want some of them. You're like, well, wait a minute. What do you mean? I only want the ones where x, in this case, is less than or equal to -3. So I'm going to use -3. Let me come over here. -4. And -5, because those are less than -3. So those are the x values that I'm going to use for my points. So, in sticking with pink here, I'm going to actually write these out. So since x is less than or equal to, we're using -3, -4, -5. And I'm going to get the y values right from my chart. So you don't have to calculate anything. We're just doing some copy stuff. So once I've got those 3 points, and we'll explain again for this one how we're picking out the x values. So we've got -3, -3. So 1, 2, 3, 2. 3. I'm just going to put little dots for right now. -4, -4. 1, 2, 3, 4. 1, 2, 3. And -5, -5, we go left. 1, 2, 5. 1, 2, 3. So here's the thing. So what do I do when it's time to connect the dots? I'm going to start at -3. Since that's an or equal to, I'm going to make a big old dot at that -3. That's my starting point. And from there, I'm going to connect the other dots, only going in that direction. I don't want to go this direction. I just want to connect those. Those 3 points starting from 3, starting from my big one. And so when we do piecewise, we're going to do that same thing for each. We're going to take the equation part. We're going to clear out whatever's in there. We're going to type in our expression, make sure we got it right. If you want to look at the picture, you can, but we really don't need the picture. So second graph will get me my chart. And I forgot to put our last step in when I was doing this last time. We're going to start at the number in the inequality. And choose 2 more. So last time, since it was less, we did -3, -4, -5. Again, if I want to have a number line at my disposal, less than goes left, so that's why we were choosing these numbers. Now this time, x is greater than. So we're going to be going to the right. We're going to be adding 1 each time instead of subtracting 1. So my x values are going to be at -3, -2, -1. I'm going to grab my calculator back here. I'm going to jot down the y values from the chart for each of those. And then I'm going to plot 1, 2, 3, 2, 3. Little dot there. -2. 5, -1, 2, 3. I'm going to make my 3 dots. This one, so I went left 1 and up 3. That first dot, wherever this number is, that first dot is always my large dot. And this time it's an open circle. Why? Because it's just greater than. It's not or equal to. So we're going to make a big circle on the 3. And again, once you make your big dot, you just connect the other ones. We are not going to concern ourselves currently with domain and range. I just want to get this graphing thing down. Because if we do, we're going to be in really, really good shape moving ahead. The trickiest part, I'm going to assume, is going to be figuring out what points I'm using. That's what we're going to kind of stress on this next one. And if there's something again with a dot or something, why did you do that? I'm serious. Stop me. Don't just sit there and go, yeah, I'm not going to say anything. Please, please, please do. Because I want to make sure we're good here. Okay. Next line to play with. Type that one in. It's negative. This is fun. It's negative for the 3 and minus for the 7. If you don't do those, you're probably going to get an error message. The negatives are always the little short ones, and the minuses are always the real long ones here. So if I pull up my chart, now I need to know I know we're starting at -1. There's no line underneath. So this is going to be an open circle. So once I get here, again, x is less than -1. Less than, we're going to the left. So -2 and -3 for my x's. Just like you were following it here on the x-axis. And so I go to -1, I put my y value. I go to -2, I put my y value. I go to -3, I put my y value. Those are my 3 coordinate points that I'm going to apply. So -1, 1, 2, 3, 4. That's my first dot. That's my big open one. -2, -1. That's just a little dot. -3, +2. That's just a little dot. And we always connect from the big dot, whether it's open or closed, to the little ones. Always big to little. And now, of course, Hardy's got to throw the screwball one in. What's this thing? Okay, x is greater than or equal to -1. Okay, if we're greater than, we're going to the right. We're getting bigger. So now y, you're like, okay, this is what, well, -5. Yeah, literally just type in -5. And we're not going to be shocked at what we see. It doesn't matter what number I plug in for x, the y number is -5. So, okay. And since my first number at -1, x is greater than or equal to. So we're going to have a closed-in dot at -1, 2, 5, big dot. 2, 3, 4, 5. And go from big dot to little dots. Keep it simple. Basically, we just have to know how to deal with the calculator button presses, and we're going to be A-okay with this stuff as far as we go on that front. Yeah.
I'm wondering what determines open and closed up.
Sure. So when we're doing these, I can even put that right here in this. So if you have just less than or just greater than, those are going to be our open dots. If we've got the or equal to with it, that's when that first dot is going to be closed. Those are good questions, though. Because again, sometimes that can mess things up if we're not careful here. Actually, I'm going to bring that to the back with us here. Just a second. Let's bring that with here. I want to do one last one before I play with a couple practice. Yeah, we need to, because I'm taking my sweet time here. Okay. Ooh. That's kind of funky. Okay. So let's see what we got rolling this time. We're starting at -5. Is this going to be an open or a closed dot? Okay, this one with an or equal to is going to be a closed. And again, we're just subtracting one each time when we're going less than. So if I had my little number line out, I just keep going to the left one each time to get those values. We learned from the last one, if there's just a number here, we'll take a peek at it one more time, but I think we kind of know what's coming. all the y's are going to be negative 1s. So let's see here. 1, 2, 3, 4, 5. There's my big closed dot to start. 1, 2, 3, 4, 5, 6, 1. And go from the big dot to the littles. Ooh. So I look at the next one, and I'm like, okay, so I got to type in negative x minus 3. Now this time I pull up the chart, and I'm like, whoa, what is going on here? So this time, I'm only going to take the two endpoints. So all I want is negative 5 and positive 1. I'm still going to get those out of the chart. And notice both arrows are just less than, so they're both going to be open circles. 1, 2, 2. Did I just go the wrong way? I think I just did. I did. Oh. 1, 2, 3, 4, 5. 1, 2. That's better. And 1. 1, 2, 3, 4. Once I make my two endpoints, we're going to connect the dots. And then I got one piece left. This one's kind of funky. If x is greater than 1, well, greater than 1 means it's getting bigger, so I'm going to add 1 each time. It's just a number again this time, so we know what we're going to see. We're going to see 6s everywhere. But this time, when I look at my inequality, I see the little line underneath. So that means it's going to be a big closed dot at 1, 2, 6, 3, 6. And so if you kind of wonder, okay, what good or what use does something like this have? Basically what it does is it starts at the left of your graph and it never runs out. So like here, it goes to the closed-in hole, goes up, comes down here, you're like, wait, it's an open circle, we don't have that value. Oh no, we're getting beamed up by the aliens here. It's the filled-in circle, and then it just keeps going. Your x values never stop, no matter what, when we're doing this. And so this is just kind of getting us ready for some graphing and function work that we're going to be doing a little bit later next part. So here's what I want you to try today. We're going to hit up some more things. I'm going to hit up some more things with you tomorrow. I'm not going to imagine we're going to go crazy here. Let's do, that's actually a good idea. Let's do that. So for today, on this 10-8 practice, we're not going to lose our minds. Okay? We're just going to be looking at odds. So I will mention one thing, because I noticed there's an absolute value on here. We hadn't talked about that. If you're on a calculator and you're trying to get absolute value, reminder, that's going to be the math menu. And then we move over to num and do number 1. But I think, to be honest, like if we were doing number 3, -7 is less than or equal to -6. Okay, that's further left in the number line. I don't think I need the calculator for that. Maybe. But even if I looked, I was like, -7 minus 8 is -15. But it's absolute value. And absolute value means it comes out positive. But you can plug things directly into the calculator too and get those answers. Do not worry about domain and range. We're just doing graphing stuff right now, trying to get used to this whole thing. So even if you're not sure on something, keep those practice ones that we did together out in the notes and just try one of each thing. Try plugging in a number and getting the value out. Try plugging these numbers in and making a chart and figuring those things out to start getting an idea of what's going on. One last thing from me. Thought I had that out, but I did not. Reminder on calculators outside of class that could be helpful. Phone apps that have all the same button presses as the calculators we have in here, and free, $100 calculator on your phone for nothing. That's a pretty good deal. I have not tested these out on to see if there was in the App Store for the computer or for an iPad or something. I assume they are, but don't quote me on that. But those are the two calculators on the phones that have all the same button presses and all the same features as the calculators that we use in class. So play with this a bit. We'll run this back tomorrow, and then we'll go into review mode for the unit test and be getting ourselves ready on that front.